Today we're going to be talking about linear functions in slope-intercept form. Now when we're talking about linear functions, first of all, it's going to involve these things. The base word of linear is line. It will always make a line when we graph it, a straight line. Now on this line, it always has a slope if it's a function. Positive slope, it's going up to the right. A negative slope, going down to the right. A zero slope, if this is a horizontal line. And then the only one that's not a function is what we call an undefined slope. This is where it'd be a vertical line going straight up and down. Now the big difference between a zero and an undefined slope, a zero slope will have a zero on the top as far as how much we rise up, and then how much we run over. This can be any number. That will give you zero. Undefined, it's going to be kind of flipped. An undefined slope, the 5 will be on top, but the 0 will be on the bottom. And if you see this in a calculator, it will give you an error message. And the third thing is, it always has a y-intercept. It always goes through a certain point, and a lot of times we call this our starting point. Now when we talk about slope-intercept form, it's made up of this equation. Y equals mx plus b. The y stands for the output, or the answer, what we're eventually going to get. The x is the input. This is what we start with. The m stands for our slope. This is going to tell you how much it rises or falls and how much of a run we have. And then our y-intercept is our b value. When we're looking to write an equation, we're looking to substitute something in for this m value and something in for this b value. The x and y will always be in there. That's our input and output. And then the first thing we're going to talk about, our slope-intercept form, is slope. When we're calculating slope, we're looking to calculate the rise over the run. Now how we calculate that, if we're not given a graph, is this formula. It is y2 minus y1 over x2 minus x1. Whoops, let me bring this back over here. So here's our formula. The important thing is these 2 points, whatever they are, and down here, there has to be a minus sign between them. I would always encourage you to put the minus signs in before you try to calculate your slope. So the first problem we have a line that passes through these 2 points, 2, -3, and 5, 8. Now it doesn't matter which one you identify as point 1 and point 2, you should get the same result regardless. But I'm going to call this one point 1, this one point 2. When we're getting slope, again I'm going to put my minus signs in first. The y2 value, x2 value, y1 value, x1 value. So I'm going to take 8 and a -3. The x values are 5 minus 2. Now when you calculate these, pay attention to the negative signs. Minus a negative changes to plus. So this fraction ends up being 11, because 8 plus 3 is 11. 5 minus 2 is 3. Leave it as an improper fraction. We don't want to change this to 3 2/3 or 3.667. Leave it as a fraction. Second problem is 4, 9, and going through 8, 11. So subtracting again, 11 minus 9. The y values on top. 8 minus 4 on the bottom. So you can kind of see that there. All these are positive numbers, so I don't have to worry about changing anything to addition, so everything will be subtracted. 11 minus 9 is 2. 8 minus 4 is 4. Now, we also want to reduce this. We don't want to leave anything that's not reduced. So we know 2 goes into 2 one time, and 2 goes into 4 two times. So the answer to this one is 1/2. Look at the letter C. This is a line that's passing through the point 15, negative 4, and 5, negative 6. y2 minus y1, x2 minus x1. So negative 6 and negative 4, 5 and 15. Minus a negative. Negative 6 plus 4 is negative 2. 5 minus 15 is negative 10. 2 negatives. The negatives cancel out. 2 goes into 2 one time, 2 goes into 10. So this reduced amount is 1/5. Now there are two special kind of slopes. Majority of them, you're going to end up like this. Either a positive slope like we had 1/2, or negative slope, depending on what it is. There are going to be some slopes that are going to result in zeros or undefined. And here's examples of both of them. Let's say we have a point that's going, or a line that's going through these 2 points. First point's 5, 9. The second one is 3, 9. When we calculate this, 9 minus 9, 3 minus 5. We end up with the 0 divided by negative 2. Again, a 0 on top will result in a 0 slope. Compared to this problem. We'll start again with that 0.59, but instead we'll make the second point 5 and negative 2. Negative 2 minus 9, and 5 minus 5. This time we get negative 11 over 0. One of the rules in math is you cannot divide by 0. This one results in an undefined slope. This does come up on occasion, and it's just one of the special ones. When in doubt, always remember that you cannot divide by 0. So that's calculating slope, given 2 points. Now what if we're given a graph? The first thing you're going to always want to do is identify, is the graph of your line positive or negative? If you can do that, it's going to help quite a bit. So looking at this first graph, this one right here, we always read the graph left to right, just like we read a book. And you want to find out where the graph crosses the corners of the grid lines. And it crosses in many places on this one. I'm going to identify them all here. So as I go left to right, I can see that my line is going down. So I know my slope for this one will be a negative slope. Now slope is also, you could call it as rise over run. We rise going up and down, and we always run to the right. To get from this point to this point, or this point to this point, our rise, we're actually going down 1, which would be negative, and we're running over 2. down 1 over 2, down 1 over 2, and this will continue. So our slope is negative 1 over 2. The biggest mistake people are going to make are ignoring whether it's positive or negative. Here's the second one. Again, we're reading this left to right. So as I'm going from 0, I see that in order to get to the next point, I've got to go up. So this one, my slope is again positive. It's going up. I see that it's going through this point here, that point there, that point there. So that's where it's crossing the corners of the grid. In order to calculate that, I'm going up 1, 2, 3 units and over 1. So my slope is 3 over 1 or just 3. Last one we're going to look at is one of the special ones. It is a horizontal line. Now remember, we're talking about rise over run. I can pick any points on here. You may pick that point and that point. How many units up or down do we go? We don't go over any. We don't go up any. But we can run to the right too. Again, if my slope has is a 0 on top, this results in a 0 slope. So there's no change in this. Now the last part of this is kind of putting this information into an equation. And once we identify what our slope and our y-intercepts are, it makes it easy to write the equation. We're filling in for the m and a b. So if it's telling us that our slope equals 2/3 and our y-intercept equals, or is at the point 0, -5. Plug this in for m, plug the second one in for b. The y's and the x's stay the same. The slope is 2/3, and the point, we want to use the y part of this part of the point in -5. We can write it as plus -5, or we can write it as y equals 2/3 x minus 5. Remember, we need to keep the x values in there. We need to keep the y values in there. Don't forget those. If we're given m equaling -15 and our b value equaling 4, we'll make this nice and easy. I'm going to erase just the m value here and the b value. I'm going to put -15 in for the m, and I'm going to substitute the 4 for the b. And we just wrote our equations. So identifying these two things, we can come back and write our equations, find our solutions, and now we can work with this equation a lot more easily.